Let us look at proposition number 8 of book 9 of Euclid's Elements. The proposition says, if as many numbers as we please, beginning from a unit, are in continued proportion, then the third from the unit is square, as are also those which successively leave out 1. The fourth is cubic, as are all those which leave out 2. And the seventh is at once cubic and square, and also those which leave out 5. Quite a mouthful of a proposition. We are given A, B, C, D, E, F in continued proportion starting from unit. Unit is not shown here. So A is the second, B is third. We know since it is in continued proportion, unit is to A is equal to A is to B. That means unit measures A the same number of times that A measures B. But we also know unit measures A based on the units in A. So we can say A also measures B based on the units in A. That means B is equal to A times A, since A measures B based on the units in A. That means B is square. Remember, A, B, C, D, E, F, including that unit in the beginning, is in continued proportion. So that means B, C, D are in continued proportion. And in this, B is square. That means D is also going to be square. If three numbers are in continued proportion, and if the first one is a square, then the third one is also a square. Instead of looking at BCD, if we look at DEF, that is also in continued proportion. And since it is in continued proportion, just now we showed that D is a square. That means F is also a square. So that means B, D, and F are squares. That means every alternate number starting from B is a square. So one part of our proposition is proved. Starting from the third number, we get squares by skipping one number. That is another way of putting this. Now let's look at the next part. Unit is to A is equal to B is to C. Say, remember, this is in continued proportion. That means the ratios will remain constant. Okay, that means unit measures A the same number of times that B measures C. But unit measures A based on the units in A. So that means we can say B also measures C based on the units in A. So now what do we have? We have C is equal to A times B. But we know B is equal to A times A, which means what? We can substitute here. So this A times A will come here. So it will become A times A times A. So that means C is a cubic number. Now let's look at C, E, D, F. They are in continued proportion and C is a cubic. So F is also a cubic. In a continued proportion of 4 numbers, if the first one is a cubic, the last one is also a cubic. Similarly, we can, if we had some more numbers, then we could have taken, let's say, C, D, F, G, F, G, H, I. We could have taken the next 4 numbers. That would have been in continued proportion. So there also, if F is a cube, then the last would also be a cube. So here again, starting from the 4th, we get cubes by skipping 2 numbers. So here we are skipping E and D. GH if we skip, then I will also be a cube. And now, if you noticed, 7th F is a cubic and it is also a square. So the 7 is both square and cubic. And if we take it further and take the appropriate continued proportion, you will notice that starting from the 7th, we get numbers which are both square and cube by skipping 5 numbers. So we have proved all the 3 parts of the proposition. That was proposition number 8 of book 9 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.